Hey everybody. Theory, this is working. Of course, I require some kind of confirmation of my existence. That's apparently how I roll. That's how needy I am. Let me know if and when you could see this. Good middle of the night. Where are you, Zapvan? You're like in the far future? Remember this. Okay. Good sound. The wave function is collapsed. I'm actually recording this with my other camera as well. So if you end up watching the QA that we post next week, then you'll see the new camera system. And then we're trying to figure out how to get the new camera system to run without any lag through the computer, because there's just like a tenth of a second, half of a second lag. It's awful. It's not worth it. You would be driven mad. And so we're recording the audio and video separately, and then we're going to be compositing that. And it's great. It's a great camera, and it actually is able to focus on my eyes. I'm quite impressed with the A7C, but you'll see. You'll all see. Thanks, Richard. Okay, so I guess we'll start the show. We'll stick around. We'll answer questions for the next hour or so. And then, who knows? Might stick around a little longer after I shut everything down. So let me just kind of get everything set up here. Okay. Remember to use all the tools, Chad. Here we go. All right. It's question show time. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I will answer them here. Now, I am doing this show on Monday, March 22nd, 2021. And so whenever you're watching this, it was live for when I did it. And so if my answers are out of date, if the aliens invade, if Starship makes it to orbit, then perhaps some of the things I say will be a little out of date. So, just understand that. Just want to give you a couple of upcoming things that are happening. First thing is on Wednesday, we've got the weekly Space Hangout, and we're going to be having our guest, Dr. Casey Hannibal, and looking for water on the moon. And many people have said that they haven't been able to find the weekly Space Hangout feed in their podcatcher, and just do a new search on wherever you get your podcast. Do a search for the weekly Space Hangout, and that you should be able to find the feed. We were on one provider, and we had to move to a different provider, and we weren't able to forward the feed to the new location. So it's a bit of a pain, and I apologize. For those of you I know were wondering where it went. Friday, Astronomy Cast, episode 600. We're going to be looking ahead. So what are some of the big space news, big events that are coming up that we're both looking forward to? And that's on Friday. I hope you enjoyed the special guests that I had last week. I had 2 guests last week. I don't have any guests booked so far this week, although I've got other guests in the far future. I've got Michikaku is coming up in April. I've got a couple of other guests in April. A bunch of other podcasts that I'm doing. So you'll be seeing all the stuff showing up on the various feeds. But as always, if there's any guests you want me to try and reach out to, let me know. All right, so we had a lot of great questions that people posted on various videos, and I want to go through some of those first before we get into the live questions. And so you'll have some time to put in all your questions. All right, let's get into it. Anton Velmosny. Hey, Fraser, can you please upload short clips from interviews, for example, like Joe Rogan does, so that people can quickly check some internet... Do that again. Anton Velmosny. Hey Fraser, can you please upload short clips from interviews, for example, like Joe Rogan does, so that people can quickly check some interesting questions from interviews and decide to watch or not? As there is not always a lot of free time, it would be great to know a small overview of a topic with some highlights. Thanks. Maybe. It's just like another thing to do. So I get the marketing reason why you would want to take the longer interviews that you do, find like the best bits of it, cut them up, have a little short version, and people can go and they can check that out, the highlight reel, and they go, oh, that's pretty cool. I'm going to listen to the whole interview. It's just another thing to do. It's just another thing. So, and I think the thing that's important to understand is that I'm not a YouTuber. Like, I know you're watching me on YouTube, but this is not my job. My job is that I am the publisher of Universe Today, which is a website that gets 30 million visitors a year. We have 15 writers in various places around the world. We're working on a ton of stories. We're staying on track of all of the breaking news, and that's my job. Right? Like the time that I'm able to spend here on YouTube is great. And I think it's really important for me to be able to have that direct connection with the people who do want it. But I'm not really trying to squeeze out every little part of the algorithm to try to build my following on YouTube. If YouTube disappeared, it wouldn't matter to me one bit. I'd just post all the stuff on Vimeo, or I would post it on Twitch, or I'd post it on Instagram. I don't really care. So I have to balance my time, have to balance the team's time on how much time we can spend doing things. And so it's one of those things that it's like if you enjoy the content that I produce, if you enjoy the question shows, if you enjoy the interviews that I do, if you feel like they're worth your time, then you kind of have to just trust me that they're going to be good. You sort of know what you're getting with me, and I hope that you enjoy them. And if you do enjoy them, that's great. And if you don't enjoy them, that's also fine. And so yeah, no, I mean, like absolutely. If I want to just like sit down and really just squeeze every piece of time and monetization and just like algorithm optimization, go ahead and smash the like button. I could. But that's time taken away from me focusing on working on my newsletter for Universe Today, managing the team, finding stories, interviewing people. And that's my job. That's my real job. This is kind of like, this is my hobby because I really enjoy it. And I think it's really valuable. And I think the purpose, all right, this is going to sound super weird, but the purpose for me for doing all of these videos and doing these interviews is to sharpen my ability to get better at what I do, to be able to be in the moment, to be able to answer questions, be able to through rote memorization, gather a lot of material and have it sort of rattling around in my brain. And I also want to be able to provide transparency to people who are interested in this field, to just sort of see behind the scenes on how this works. And that's about as far as it interests me. And I'm not trying to run a YouTube empire. I don't really care. So I think that's why I don't do a lot of the things that you see a lot of YouTubers do. Just because for them, for a lot of people, YouTube, like, this is their platform. They have to be on this platform. If they don't nail this platform and do it right, then they're out of a job. And that's where I'm different. Or that's where what we do is different. And so I think, so I don't think we will, but who knows? I mean, we're always looking to repurpose our content and use it in different ways. And maybe you'll see short clips of this show up on other places. I don't know. It's like you could work forever, just forever. You could just there's opportunities a mile long, and I could just get up in the morning and just go, hustle, work hard all day long, go to sleep, get 3 hours of sleep, get up the next day, and it would still be a bottomless amount of work that I could do. And at some point you just kind of go, that's enough. I'm done. I've done what I want, and I've done what I can. And now I'm just going to play some video games and watch some shows with my wife and hang out with my kids. And yeah. So anyway, that's my take, just sort of in general. As I'm like, yeah, I could do that other stuff, but is it like fun? Not really. So that's sort of the purpose of this, is to entertain me too. All right. Micro Chandran. Hey, Fraser, what type of stars are visible to the naked eye in the night sky? That is a great question. I know I always say that's a great question, but that's a great question. Because we're actually seeing a very specific kind of star in the night sky with the unaided eye. So the most common stars in the universe, of course, are the red dwarf stars, and they are everywhere, and they are dim, and you can, but you can't see them. Like the closest red dwarf star to us, Proxima Centauri, you can't see without a telescope. And the rest of them are all not possible to be seen. So the stars that we're really seeing are the bright stars. Stars as bright as the sun, or actually like a lot, much brighter. Stars that are multiple times the mass of the sun, stars that are dozens of times the mass of the sun. And so when you look out into the sky and you're seeing all these stars, you're actually seeing very extremely massive stars that are often very far away from us. They can be, like we know that Betelgeuse, which is one of the brightest stars in the sky, is many hundreds. Let me get some water. Whew, all right. So when you look at, say, Betelgeuse, which is one of the brightest stars in the sky, we know that it is like 650. I know the numbers change. Somewhere between 500 and 600 light years away. And while Alpha Centauri, which is a very bright star in the sky, is only, say, 4.5 light years away. And so the vast majority of those stars that you see, they're all actually really hot stars, which is or giant stars. And so we're actually seeing a very warped version of how the universe truly is. Tyler Vandeven. How long did it take for the solar winds of the Carrington event to reach Earth? Would you be able to reduce the damage by having a planned shutdown of all the power grids until it passed? I know they do that with satellites when the sun has a solar flare, and it keeps them safe. Yeah, well, so when you have a severe solar storm that impacts life here on Earth, you get this chain of events. So you get this really, really powerful flare on the surface of the sun. And then it takes about just over 8 minutes and 20 seconds for the photons to go from the sun to reach the Earth. And so that's where we get our first warning that something big has happened on the sun. After that, you get some of the faster particles arriving quite rapidly after the solar flare comes by. So you get these things called, let me see here. Yeah, so the first thing you get solar energetic particles, and they can come within 20 minutes to several hours. And it just depends on the strength of the flare. And then, and this is sort of the big one, is you get the bulk plasma that was ejected. And that is just all of that material, that hydrogen that's blasted off the surface of the sun. And that takes anywhere between like a day and 3 days to arrive. Again, it sort of depends on the velocity. It depends on the force that it's been thrown off of the sun. And that's the stuff that interacts with the magnetic field here on Earth and can cause damage to our electronics. So one of the big goals of space weather is to actually be able to tie together to see, okay, we saw a flare of this power on the sun, it was pointed in this direction, and then we know that this regime of particles is going to arrive at this time, and then those particles are going to arrive at that time. And then you're exactly right. Try to be able to disconnect pieces of the grid, shut down really special parts of satellites and try to be able to minimize the damage that we're going to experience here on Earth. And that's one of the main goals of all of the various space observing that's happening right now with all the different satellites. And the more we learn, the safer we can be into the future. All right, so those were the questions. Yes, Chad, I'm recording. Those are the questions that I had prepared, and now I want to take the live questions. Oh, it's funny. People always want to know about my thoughts on media, but sure. I'll do this one. Raphael Dominichini. Are you going to watch the TV series Foundation based on the books of Isaac Asimov? Absolutely. I would say the Foundation books are some of my favorite science fiction books ever. Although, recently rereading them, I reread the Foundation books about 2 years ago, and they didn't really hold up. They're great, and when I first read them, they blew my mind. But this time around, maybe I'm a little more jaded. Maybe the ideas have, it's kind of like watching The Seven Samurai, and you're like, oh, I've seen these ideas. Come on. A bunch of ragtag group of heroes forming to defend a town, and the number is 7, yawn. But of course, the Seven Samurai, defined the genre, and so maybe Foundation did the same thing. But yeah, am I going to watch the show? Of course. Like I would watch, I'd watch almost every science fiction series that comes out. I'll give them a shot. But people always want to know if I'm excited about stuff, and I'm almost never excited about upcoming shows. I watch them. If they're good, awesome. If they suck, that's too bad. But I never get my hopes up. Like everything just has to stand on its own 2 feet. All right, this is a good question. But I'm going to change your question so that I don't get hampered by the algorithm. Mitch Harpino. If I robbed a bank on Mars, how would I be prosecuted? When we think about the future of humanity in space, and as we live on other worlds, we're going to have to start thinking about space law. And the reality is that there already is a certain amount of work that's being done in space law. And the background law that everything has to fall under is called the Outer Space Treaty. And this was signed like decades ago by pretty much every spacefaring nation on the planet. And really the main goal was to say space is a wilderness, kind of like Antarctica. So nobody can own it. And nobody definitely can ever put nuclear weapons in space. Like that's just like rule number 1, no weapons of mass destruction go to space ever. But they didn't put a lot of energy into thinking about just like ownership of things like that. And so as the rules are defined right now, if you build a base on Mars, if you build a bank on Mars, and that bank is actually a research station by your country. So it would be I'm not sure where you live. Let's say it's an American research station. And anybody is allowed to come and use the resources of your bank, and you can't stop them. So it's actually impossible to rob a bank on Mars because you have to essentially provide shelter, you have to provide all of the benefits of your station to anybody who shows up, because it's in neutral territory. So it's actually currently impossible to rob a bank. But you would expect at some point people are going to figure out like a law about this. And the way it's going to work is essentially if it's an American bank that's on Mars, you're going to be following under American law. Now the challenge will be for them to actually prosecute you, to find you on Mars and bring you to jail. But in the future, of course, if and when Mars ever secedes from the Earth and becomes its own nation, then you'll fall under Mars law. And I'm sure they have all kinds of rules for that. But until that actually happens, you as a citizen of whatever country you come from will be tried under the rules of, it's sort of in exactly the same way as if you, I don't know, rob a ship in the middle of the ocean or rob an Antarctic research station. So, yeah. Sorry, just looking at questions. Apologies. Nancy Graziano saying if YouTube disappeared, Weekly Space Hangout would be in deep doo-doo. No. We just use some other service. Twitch, Facebook, whatever. Be fine. Right. Move that question down. Okay. I don't know how to say your name. Hold on, I'm going to have to go to Google Translate. It's in Russian. Let's see. Mikhail Banikov. Okay. Mikhail Banikov, what do you think will be a braking solution for future spaceships that will travel some percentage of the speed of light? Slowing down with thrust appears to be way too wasteful. Yeah, when you send a spacecraft to another star system at some significant portion of the speed of light, the best way that we have thought to do this is probably going to be with some kind of laser system. Yeah, I know the sun is coming in right now. I've got my blinds are off. It'll be blocked in just a minute. So, yeah, let me do this again. So when we try to send a spacecraft to some other star system in the future, the best idea that's been thought of so far is to use some kind of laser system and a laser sail to accelerate a spacecraft to a high velocity, and then it will coast the distance to reach the other star system. And the challenge, of course, is that once you accelerate the spacecraft to a very high speed, but you don't have some way to actually slow it down again on the other side. Like, you're not going to have some laser system that's there to catch your spacecraft and be able to slow it back down again. And so what's going to happen is the spaceship is just going to fly right through the star system, take a bunch of pictures, send some pictures home, and that's that. So what can be done about that? And there's a couple of ideas. You need a system that isn't going to use propellant, because if you're already going, say, 10, 20% the speed of light, there's not going to be some easy way for you to be able to decelerate yourself again once you reach the other stars. Like, if you can't accelerate yourself to 20% the speed of light, you can't decelerate yourself to 20% the speed of light. It's going to be impossible. So you're going to need some other system to be able to do that. And the best idea that I've seen so far is that you essentially extend a magnetic sail out from your spacecraft. That's sort of like a solar sail. And then what it does is it interacts with the interstellar medium that you're plowing through with your spaceship. And each individual particle that you interact with this mag sail will slow it down a tiny little bit. And so you'll be able to bring yourself down from, say, 20% the speed of light down to, regular speed. And then you will need some kind of propulsion, whether it's like some kind of ion engine or something like that, to be able to slow yourself down to the point that you're actually able to go into orbit. So that's the best idea that I've ever heard. Otherwise, it's like if you can get yourself up to speed, then you can have a way that you can bring yourself back down from that speed. And so that you're going to need, if you can have a fusion engine that can get you up to 20% the speed of light, then a different fusion engine will bring you down to 20% the speed of light. That sun going to behave? Wow. All right. Yeah, welcome to, man, I think I need to put a block up on that. I think I'll do that. The rest of the video will look weird. I'll use it. Let's see. There we go. That's better. Ludicrous speed. All right, this is awesome. Okay. Yaw man. I have a question. Can you put to rest all the theories that are spreading around the internet about catastrophes and crap, please? I have been trying to do that for 22 years now. And it hasn't taken yet. So, I'm doing everything that I can, by being just like, I'm just going to keep talking the science. I'm going to try to just outlive all of the nonsense conspiracy theory that goes on. You know, it'll never go away. It's impossible to make it go away. We have been like battling, give you an example, like Planet X, right? This idea of Planet X, that there's going to be some mysterious planet that's going to be passing through the inner solar system. It's going to flip the Earth's poles and usher in the age of Aquarius or something like that. That was running around the internet when I started Universe Today in 1999. Like it was earlier than me. And yet me, Phil Plait, the Skeptic's Guide to the Universe, like all of these people have been battling these conspiracy theories. And YouTube just put that on steroids. Like YouTube gave people with even a passing interest in just space a way to go down the space conspiracy, flat Earth, Planet X rabbit hole, and has only recently been able to sort of shut off the fire hose. They haven't directed it towards science. I'm not sure where it's going now, QAnon or something like that. But they have not. But at least they're not driving people into conspiracy, into waiting arms of conspiracy theory. So all I can do is just talk about science. And if people show up and they like science and they're into it, then they will enjoy the channel. And if they've got preconceived notions about various conspiracy theories that have been put into their brain, then there's no way to really talk them out of it. And I actually don't think, like when I think about a person who is into Planet X, for example, I think they're more interested in, or like UFO abduction. I'll use UFO abduction. I think they're more into the idea that they know something that the mainstream doesn't know. That it's more about being part of the in crowd than it is about genuinely being interested in the answer to these questions. Because there's plenty of evidence. There's plenty of people who have dedicated their lives searching for evidence, who have other opinions. And yet, you know, obviously people don't listen to it. So no, I can't. I can't do anything about it. All I can do is I can just outlive them. I was here for 2012. Do you remember 2012? You know, we were posting dozens of articles about what was not going to happen in 2012. And that's like 8 years ago. Nothing happened as predicted. And so nothing is going to happen into the future as predicted until something does. But that's like, you know, a billion years from now. So don't worry about it. Oh. Jonathan Allen. My child is 7. Do you think that he will see a human come back from an interstellar trip in his lifetime? Interstellar? No. Interplanetary? Sure. Yeah, I think that your child will see people go to Mars and come back home safely. In his lifetime, there will be a tremendous amount of people flying between various places within the solar system. Between other stars? No. If you do the math, like if you just literally just take the math of the amount of energy that has been used by humanity over the history of humanity, you go back 1,000,000 years, even 100,000 years, there's a smooth curve of how much energy used. It's a logarithmic curve. It's an exponential curve of how much energy humanity is able to muster. And that number just keeps going up. And so we can expect that that number will keep going up into the future. And at the same time, you look at the amount of energy it will take. We talked about this earlier in the show about trying to send a spacecraft to another star system. You need to generate enormous amounts of energy. Those cross in about 700 years from now. So the amount of energy that humanity is able to produce crosses with the amount of energy it takes to fly to a star system without bankrupting humanity. It's about 700 years, 800 years is the prediction. And so now maybe your child's going to live 700 or 800 years with modern medicine and robot body. Of course, I'm going to live 800 years as I may go through a couple of robot bodies, but realistically, in a time that you could be patient for, no. But interplanetary, absolutely. Really, the good stuff is going to be happening in about 150 years, 200 years from now. That's when the solar system will look dramatically different. People are asking if I applied for Dear Moon. I think I covered that last week. No way. Not going on Dear Moon. Okay. Sean Marson. Hi, Fraser. I would love to hear your thoughts on the practical use of an Earth-Mars cycler transfer orbit. Is it worth the risk? Thanks. Now, I'm not exactly sure what you're talking about, but essentially you're just talking about like a ferry system that's going back and forth from Earth to Mars, interacting with the two planets gravitationally so that you can essentially transfer astronauts from Earth to Mars, from Mars back to Earth. I think Buzz Aldrin was a big proponent of this idea. And I think the idea is great in theory, that you've got this permanent way of getting people to and from planet Mars. It's this idea, and I talk about this a lot, this idea of infrastructure, that our existence in space becomes easier and easier once we have more infrastructure. Right now, every mission that we try to do to send humans out into space, we have to carry all of the infrastructure with us. We have to launch the spacecraft from Earth with a capsule on top that contains all of the supplies to get the humans to, say, the moon and back. What if we've got some orbital fuel depot that a starship can fly up to, dock, transfer fuel, and now it can go way farther? Infrastructure. What if we have one of these orbital fuel depots out at Mars, where spaceships can go and dock there and transfer fuel and fly to other places in the solar system? Infrastructure. And what if we have some regular spacecraft that is constantly making the journey back and forth from Earth to Mars, carrying people in both directions? That would be amazing. You could totally up-armor it. It would be a lot safer from solar radiation. It would be sort of like a very comfortable way. You could still do science. It'd be like the space station, but you are making this journey to and from Earth to Mars. So I think just in general, and even, we see that here on Earth. You build an internet, you get value. You build an international, like a interstate highway system or interprovincial highway system, and you get value from it. And so always there's huge value in building infrastructure in whichever way that works. Fuel depots in space, space stations that are positioned at Lagrange points, which can act as gateways to other places in the solar system. All of that stuff will help sort of make our lives, our exploration of the solar system easier and easier and easier over time. 37. A bunch of people asking, yeah, no way. No, am I not going on Dear Moon? I want to live. How will I get my robot body if I die in space going around the moon? Yikes. All right. 6 Bob Ohms. Fraser, since the GMT mirrors just fit inside a starship, should we send some to the moon and build a lunar GMT? So I did a video a couple of years ago, maybe at this point, about the idea for building the overwhelmingly large telescope, but building it on the moon. So building a 100-meter telescope, but instead of it being on Earth, you build it on the moon, where the gravity is 1/6, and so you can build it with 1/6 the support, and so it's actually like the perfect place to build a telescope that big. Or you could scale it up, and you could build one that has 6 times the mass, and on the moon. And if you were actually able to build a telescope that big on the moon, it would be, think about the size of the Hubble Space Telescope. Imagine, 2.6 meter telescope. 2.4 meter telescope, space telescope. And if it was on the moon, 100-meter space telescope, it would be crazy what you would be able to see. You'd be directly imaging planets. You would be seeing right out to the edge of the observable universe. It would be the most wondrous tool. But even trying to go and set up on the moon is a bit of a pain, and you still are dealing with gravity. Why go to the moon when you can just be in space? Then you could build a space telescope of any size. You could build a telescope that is 1 kilometer across, and there's no gravity. So it's just about building all of the trusses to make sure that the mirrors stay in the right shape. But you don't have to worry about supporting the weight of the telescope. So I think that if you want to build a big telescope, just space itself is going to be the place that's going to make the most sense. We're going to move from large space telescopes being launched in a spacecraft one time to this future where we build interferometers in space, multiple telescopes flying in formation as big as we can possibly make them. And then over time, you just add more and more telescopes to this fleet of spacecraft, and your telescope just gets bigger and bigger and bigger. So maybe the biggest possible telescope that you could load up into a starship is 20, 30 meters across, folds out, maybe you go down the route of actual assembly or even manufacturing of the telescope portions in space itself, and then you could build one that's kilometers across where you're 3D printing trusses, and then you're laying down your telescope material on top of it. Yeah, you could have a telescope that's 10 kilometers across. It's just a matter of launching enough spaceships. So we don't know what the future holds for telescopes. We do know they're going to be big, and a lot of it is just it's going to be the next phase of telescope construction is us building giant telescopes, interferometers in space. LUVOIR will probably be if it ever gets built, it'll be like the last telescope built the old way. And all the future telescopes will be built kind of like the International Space Station, assembled in space in parts into bigger and bigger observatories. And then you just put a second telescope that flies in formation, and now you've got an interferometer that's acting like the distance of the two telescopes. So, it's gonna be great. But don't go to the moon. Except if you want to build a radio telescope. Then it's the perfect place. Inzo, are there any pictures or videos that accurately depict what it looks like? Oh, let's see this again. Inzo, are there any pictures or videos that accurately depict what it looks like to look at the vastness of space from space with the human eye? I know the exposure of cameras is a difficult factor. It would be very easy to depict what it would look like to see space from space. If you were an astronaut on board the International Space Station, and I've talked to them about this, what they say is that the stars themselves are much brighter. That, in fact, the stars are so bright that you have a hard time telling them apart. And so here on Earth, where we've got light pollution, we've got the atmosphere, clouds, things like that, we're familiar with constellations. But the astronauts I've talked to, once you get up into space, you can't find your constellations, even though you know them. Like, you could have been an amateur astronomer all your life, and if you go to space, you have a really hard time recognizing, oh, there's Orion, because all of the stars that are in the constellation are all really bright. All of the stars everywhere are really bright, and you don't have a lot of time as you're sort of whipping around the Earth to be able to sort of get your bearings. And the astronaut I was talking to, he found that very disorienting, because he was expecting, as an amateur astronomer, to go to space and go, okay, it's going to be just like I did on Earth, but now I've got, like I'm a human Hubble Space Telescope. This is going to be the best. And he said, actually, it was really tough. You could see the moon, you could see some of the planets, you would recognize those, but the actual stars, it was rough. Once you're actually like thinking about some of the other things like nebulae, galaxies, things like that, they actually don't look very good at all, even in space, because you do, as you mentioned in your question, you need the long exposure from a camera to show off the fainter stuff in these objects. And so you could be standing right beside, in your spacecraft, right beside the Orion Nebula, and you wouldn't really see it. Even if you got close, like you're right on the edge of the Orion Nebula. Well, then as you get closer, the nebula spreads out, and so the light is spread out over a much larger area, and so it wouldn't look very good. But there are a few objects that would look pretty cool. I mean, if you could get close to a black hole and see the accretion disk, or say a globular cluster, you get closer to one of those so that it filled the sky with a ball of stars, that would be pretty great. But nebulae, galaxies, there's pretty much no place you could go that would make them look better with the unaided eye. Once you take a telescope, then absolutely, telescope, camera, get them very close, it's going to look great. Let's see. Basket of puppies. If aliens live in the fourth dimension, we wouldn't see them, right? No, we could see aliens that lived in the fourth dimension. We just wouldn't be able to see the way they actually looked. We'd only be able to see a three-dimensional projection of their four-dimensional nature. And you could do this, you could think about, say, what does a cube look like seen from two dimensions? You're essentially just taking slices through a cube. And so you see different shapes. If the cube is face on, then you're going to see a square. And so if a two-dimensional creature would experience a cube as it passed through their plane in different shapes. Maybe when the cube first started, if it was coming in corner side, it would look like maybe a triangle. And they'd be like, what's this weird triangle? And then the triangle would get bigger and bigger. Or if it came through sideways, then they would see a square, or maybe they would see a rectangle or a parallelogram or something like that. And they would experience a cube. A circle passing through a sphere passing through a plane would be a circle. It would start as a small circle and get a bigger circle. And so you can kind of imagine different three-dimensional objects as they pass through a two-dimensional plane. A creature that lived in two dimensions would be able to experience different shapes based on the angle of the three-dimensional objects that pass through the plane. And so if you scaled up everything one more notch, you would have four-dimensional creatures, four-dimensional structures passing through our three-dimensional universe, and we would be able to see a projection of it. We wouldn't be able to get its actual true four-dimensional nature, but we would be able to see something, and which is kind of cool. It's dimensions. One of the things that's neat about dimensions is like the math explains everything that you would want to know about it, but you can't actually experience it with your own senses. You can calculate what things will do, what a four-dimensional cube looks like, or how it behaves, and yet you couldn't actually look at one without going crazy. So, or even look at one. So it's a neat idea, and of course, this is one of the ideas that if we, one of the possibilities when you sort of think about like how could you fly through the universe, a finite universe, and return to your starting point, even though it's three dimensions. Well, if you're a four-dimensional creature, it's easy to understand. They're surprised that we don't get it because we're trapped in three dimensions. We can't comprehend how that would work, and yet it's a perfectly reasonable possibility to explain why the universe is flat, and how you could, and if it's finite and flat, then yeah, if you went in any one direction, you would return to your starting point after a finite amount of time. So people are asking about Tianwen, and I don't have any insights. I should though. I know they're gonna land. The plan is to land soon, but I haven't heard an updated date on it yet. That's a good question. Let's see. Sorry, it's such good questions. All right, just refresh. Walid Damuni. If we collect the solar ejecta, will we find regular atoms in it? What elements are there and what ratios do they exist in? The solar wind is material that is streaming off of the sun. The sun is made of mostly hydrogen and helium, and the solar wind contains atoms of hydrogen that are being blasted off the sun. Protons, really, when you think about it, because it's hydrogen, but it's just one proton. And then you've also got electrons and various plasma, various levels of ionization. But it's just regular elements, just hydrogen, helium coming from the sun, and and hydrogen, helium, and electrons coming from the sun. Larry Beckham, did you know the Starship BFR stack to orbit cannot launch from land? Too loud. Must launch from a rig in the Gulf of Mexico. Is that true? I'm not sure. I mean, too loud? Too loud for what? Too loud for human beings nearby to handle? Too loud for the acoustics not to shake the rocket to pieces? I mean, definitely from just like being a good neighbor. The Starship is going to be super loud, and so I think the plan is they're going to have these things. I know that SpaceX has purchased a couple of old oil rigs called Phobos and Deimos, and they're going to be trying to eventually launch these things from these rigs off the coast because they are going to be so loud and also kind of dangerous. I mean, we've already seen a couple of Starships explode. Super Heavy is going to be this enormous stack, this bomb. And so it makes sense to try and launch this thing away from just land, humanity, everything. But it is, when you think about the practical realities of having these things take off and fly around the Earth. And, like I know one of the ideas is that Starship could eventually be a point-to-point system for getting human beings around the planet, which I don't think that'll happen. Like, it's just like, I think it's still going to be too expensive compared to just taking an airplane. Like, being able to cross the planet in 15 hours is fine. That's fast, as opposed to being able to do it in 45 minutes for $1 million, right? But maybe, there'll be some times when you need to send a shipment to the other side of the Earth. But anyway, but I know, they've already bought the rigs, and I know they're going to be converting them, and they're going to be launching them off of these rigs. So I'm sure that's the long-term plan once they've settled on all of the challenges. It's going to be crazy. Again, the mind just sort of boggles at the scale of Starship and Super Heavy, and the possibility that we're entering an era of fully reusable 2-stage rockets, where the launch costs are cheaper than any rocket system that's ever been built. It's, again, just mind-blowing. Horizon Brave. So we know stars and planets formed X amounts of years after the beginning of the universe, but are there still stars forming right now? I don't mean when we see the light, but actually. Sure, yeah, there are stars forming across the universe right now. Now, when we look out into space from our position here in the Milky Way, we are looking backwards in time. And so as we look farther and farther, we see Andromeda as it looked 2.5 million years ago. When we see giant galaxy clusters, they could be 100 million years ago. And some of the farthest galaxies we've ever been able to see, we're seeing them as they looked 500 million years after the Big Bang. And if we could look at them today, they would look similar to the Milky Way. But we're seeing them at an age when they were a lot younger. And we know that the majority of star formation was happening when the universe was just a couple of billion years old. That was the time when there was like the most amount of raw hydrogen fuel that was available to produce stars. And so the bursts of star formation, the universe party happened just a couple of billion years after the Big Bang. And now we're already on this slow decline. But there are still stars forming. There's about one new star forms in the Milky Way every 100 years. Wait, is it? I'm going to see this two ways and then chat can edit the one that was wrong. Because there's one star forming in the Milky Way every year. Or there's one star forming every 100 years. I forget which one it is. Someone in the chat can tell me. And now I'll have to memorize this. Anyway, but there are places where there are galaxies where they are forming stars 10 times as fast as the Milky Way. And in the future, when the Milky Way and Andromeda merge with each other, we will go through another period of rapid star formation. And, people always, there's that saying, that when you look into space and you wish upon a star, that star is actually long dead, just like your dreams. And that's not true. Every star that you're wishing upon is only just a few hundred light years away. All of those stars are still there. All of the stars. The farthest we could see in the Milky Way is still maybe 30,000 light years away, 30,000 years. So the various parts of the Milky Way that we're seeing, they're not that long ago. And there's plenty of stars still forming. And so when you see new stars forming in the Orion Nebula, they're forming like effectively right now. Yeah, maybe 1,000 years ago, but essentially now. They're going to continue to form for a few million years, explode as supernovae. The cluster will fall apart and the stars will join the rest of the Milky Way. But yeah, plenty of stars still forming all over the place. My stream seems really quelt compared to other streams. I don't know what that means. My stream is just as quelt as every other stream. All right, one more question for the QA. Okay. Hiroshi loves you. Hey, Fraser, what are your thoughts about landing on Mercury? Yes, we should absolutely land on Mercury. Why is nobody doing this? Why are there no plans for a lander for Mercury? Mercury is actually a really fascinating world, and it's got a lot more going for it than, when we imagine Mercury, we just imagine someone just took some metal and rock and just baked them in the oven, and it's just this awful place that's brutally hot. But the reality, of course, is that Mercury is just like the moon. Half of Mercury is in scorching sunlight, and half of Mercury is in eternal shadow as the planet turns very slowly. So it's not eternal shadow, but anyway, at any point, half of Mercury is in sunlight and half of Mercury is in shadow. Half of it is super high temperature, half of it is extremely cold. And Mercury has permanently shadowed craters at its poles, just like the moon does. And it's possible that there are reserves of water ice in the poles of Mercury, just like there are reserves on the moon. We're all excited about water on the moon. There could be water on Mercury. And Mercury tells us, Mercury is made of metal and rock, a very fascinating world that's very close to the sun and has a lot of really interesting secrets to share. And I would love to see a spacecraft, a rover, a lander, something to go to Mercury. There's plenty of power. It's so close to the sun that the solar panels will get a tremendous amount of energy, and yet and you can just sort of dip in and out of the sunlight and the shadows and be able to explore on Mercury. So yeah, I would love to see, and I'm sure somebody has proposed an idea for a lander rover system that would go to Mercury. I'll look into it because I think it's great. Mercury is it's a forgotten world, but it's fascinating, and we should absolutely go back. Way easier to get down to the surface than, say, Venus. And Mars is cold and not hard to use energy that far out. But Mercury is well worth exploring. And there's some really interesting terrain that's been seen on Mercury. Yeah, Mercury for the win. Now I'm all about Mercury. Now I'm stoked on Mercury. Sorry, Ganymede. Take a step back. Mercury is my favorite place now. Yeah. All right. I got to do a couple of bumpers now. But I'm going to do my bumper, my outro, and then I'll stick around and I'll answer a couple more questions. So, more questions in a second, but first I'd like to thank our patrons: Rob Bennett, Tony Lazar, Chris Clow, Joe Torres, Brad Bryant, Ron Thorson, and the rest of our 847 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Outro. If you want a single comprehensive resource for space news, you're going to want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thank you to everyone watching here and on Twitch and everyone who asked a question. Now, if you want to ask a question for an upcoming show, you can post it in the YouTube comments or in Patreon, or you can join me live on my YouTube channel every Monday at 5 p.m. Pacific time. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right, and now I'm going to try stopping the recording. Did that work? It made a bloop bloop bloop. Okay, I'll stop the audio. And I'm sure it all broke. But cool. So it makes me happy for humanity. Fraser has almost 1,000 Patreon subscribers. Yeah, people, again, Patreon is cool, but it's not really it's about a quarter of our revenue for Universe Today, maybe a fifth. So most of the revenue for Universe Today comes from advertising on the website. And I could go a lot harder with sponsorships and advertising and all that, but it's just like it's effort that I don't want to go into. I don't want to take the time to talk to sponsors and coordinate and write scripts and all that kind of stuff. And so, we make enough money from advertising on Universe Today as well as the patrons to be able to pay all of the freelance writers and allow me to run the website and again, it's sort of like what makes me happy, and not having to sort of extract every dollar out of the system makes me happy. So that's great. This is how the sausage gets made. Will the solar wind cause the Earth's orbit to degrade? No, it's just there's just not enough material going through space to really cause us to degrade. Now, if once the sun turned into a red giant and if the Earth hadn't actually migrated away and was orbiting inside the atmosphere of the sun, then then you got a problem. Then you're spiraling inward. Simon Farmer, I'm happy that you get to do this, although I bet you were good at the computer stuff too. Yeah. I'm very good at the computer stuff. In my former life, I was product manager for software companies. I was an executive at a web development firm in Vancouver. Companies that I've helped found are now publicly traded entities on stock exchanges. It just sucked. I didn't enjoy it. The purpose, I talk about like university is its job is to make me happy, and I'm serious. Like I could do lots of other things. But many of them suck and are not fun, and you find yourself not enjoying your job. And it's like, if you're not enjoying your job, spending more time, like there was crunch time in the video game industry where you have to deliver some big project. I had to lead a team on crunch and have them show up every day for longer and longer hours as we try to deliver on a big project for a customer. And in the end had to work, I think I had to work like a 48-hour day to deliver the project as we had promised, so we could get paid, so that we could pay everybody's salaries. And then everybody quit because they all had to work really long hours. That sucked. When you have a customer tell you, when they want your advice on what to do for their website or their project, and you give them your ideas, and you don't want to, Michael Meyer, you can go on forever because you can't shut the stream down. I think my ideas are good ideas, and I just want to implement them, and I don't want to have to convince somebody else to implement them. So if I'm like, we're going to make videos about this, I just do it, and then I don't have to talk to anybody about it. Well, for sure. I talk to Chad and Nancy and other people, but it's really about building, as you get into business, you can either go one way and just try to make as much money as you can, or you can go another way, which is just try to make a lifestyle. And I have absolutely created a lifestyle business with Universe Today. It allows me to live in a small town in Canada, have a house, and I get to employ a bunch of people, and I get to choose my schedule. I get to drop what I'm doing and play video games in the middle of the day if I want to, and often do. And I never have to explain my ideas to a customer. Like if my ideas are bad, then they fail. but I don't have to try to convince somebody that my ideas are good and then no, thank you. So yeah. But then you are the boss. Yeah, that is the downside, is that you know, there's this saying in business, right? That everything rolls downhill. Everything's your fault. And so if the web server is down, it's your fault. If somebody, if you get a copyright strike from YouTube because you posted some NASA footage in one of your videos and now your channel is being threatened to be taken down, it's your fault. It's your problem. You got to deal with it. There's the buck stops with me every time. And most of the time, it's not a problem. And most of the time, you got the freedom. And then every now and then, it's a living hell that you have to deal with because no one can fix it. You can't rely on anybody else. It's up to you. That sucks. Menghua Hung is saying, please live stream when you play a game. Yeah, I probably not, because I have to like drop out of games that I'm playing and be able to do work and stuff. So I would be a really bad player. I mean, and then I think about the games, like right now I'm playing Path of Exile, and I'm playing Loop Hero, which is pretty. I'm still not sure if it's any good or not. But and the game that I'm really good at is RimWorld. But I don't know if I would want to stream games. I'd rather just hang out and chat. Because I'm sure if I was like playing a game, people would want to talk to me about space. So I'd rather like get a telescope going and do some live streaming of space and things like that, as opposed to playing a video game. Have I done some books? Yeah. So I used to write. I used to write for the role-playing game industry. So if you do a search for my name, I've written a couple of books for the Shadowrun universe. And I wrote a book for Earth Dawn, which was the fantasy version of Shadowrun. I've written a book for GURPS from Steve Jackson Games. And then I did a bunch of proposals. A bunch of other books that I did got kill fees. And then, of course, we have actually published a couple of books with Universe Today, sort of. Dave Dickinson did the Universe Today Guide to the Cosmos, and there's also his new sort of Observer's book. And I was heavily involved in the first book, not the second book. So, Simon Fraser, RimWorld's a great one. Naked Alone. Yeah, no, I play the hardest level on RimWorld. I don't play the Naked Brutality one, because if you don't play those RimWorld, like the hardest possible version you can do. Well, actually, hardest possible version is you can crank up the difficulty scale way beyond. But the one that I like is the Cassandra Merciless, because it is merciless. You got to play perfectly, and it ramps up really hard. But I don't like the Naked Brutality because there's too many sort of random chance things that can happen to you early on that sort of set you right back again. So I usually just do 3 colonists, Cassandra Merciless, go. There you go. Someone's posting some links to some of the books. Yeah. I used to organize role-playing game conventions in Vancouver, and I used to write for the role-playing game industry, and that was like, I mean, we're talking like 25 years ago. Like, I think I wrote my first book when I was 19. So, I don't like writing books. It's awful. It's super hard. I like writing shorter things that you can collect into a book later. I mean, I like to write, when you think about, say, I've written 450 episodes of The Guide to Space. Each one is, say, 1,500 words. It's like the equivalent of 5 or 6 books. Ludwig Lima Nunez. Do you like the Mars trilogy by Kim Stanley Robinson? Yeah, I like it a lot. I wonder if it still holds up. Arshon, can you see the Vandenberg launches from your house? No, I'm a little far north from Vandenberg. I'm about 1,500 kilometers north from Vandenberg. Yeah, Moochie the Cat. I used to be friends with the Columbia games crew who made Harn from that neck of the woods. Yeah, they're from Vancouver. So I used to work in a comic book store in Vancouver, a place called The Comic Shop. And I ran the role-playing game department of the store. So I handled all the Magic cards, all of the D&D role-playing games, things like that. And the Harn folks would come into the store every now and then, and I would talk to them. I think we had them at the conventions that we did as well. Dustin King, I like that Universe Today isn't paywalled. So many news sites are doing that. Yeah, Universe Today, I mean, assuming I can figure this out, will never be paywalled. I really don't like paywalling content. And especially like educational content, I think it should be free. It should be freely available to anyone who wants. In fact, I don't know if you noticed, but I actually put Creative Commons 4.0 on everything that I do. So all these videos, all the videos that I release, all the interviews, they're all Creative Commons. So if you want to like remix it to some video you're working on, you can do that. As well as all of the content on Universe Today is Creative Commons as well. So if you want to include anything from Universe Today, you can do that. No problem. And Patreon is like the perfect system for that, because it allows the people who are really into it to support us, and then we can still make the content freely available to the world. And yeah, no, we will never paywall Universe Today. I mean, I never say never, but something would have to dramatically change because I mean, if we had to, then it would just be me writing stuff on Universe Today, and Patreon would be able to support just me. But the advertising is what the advertising is what allows me to have a team. And so I don't think we'll ever get to a point that Patreon will cover the cost of the entire team. But that's why if you join our Patreon, then we remove the ads from the website. And so you see the ad-free experience. So, and that's sort of like the equivalent of a paywall, but yet all the content is still freely available. Arjun, did you check to see if you had any expensive Magic cards, like really rare ones? I had a Black Lotus that I sold for $300 a few years ago. In fact, I still have a box full of Magic cards, piles of alphas and betas and stuff, but all the good stuff's gone, long gone. I was thinking of actually eBaying a bunch of the stuff just to sort of reduce the amount of atoms that I have. But yeah, no, this interesting story time. So when I used to run these conventions in Vancouver, the Wizards of the Coast were just across the border down in Seattle. And so the folks from Wizards of the Coast called me and they're like, we've got this game that we've made. Could we come to your convention and set up a booth? And and I didn't have any booths at my convention. I'm like, yeah, sure. Just come on by. Just come and hang out and demo your game. And so this was before Magic. their game, Primal. It's like some game about gods that you could play. And so then, like the year after that, I went to Gen Con. I did a road trip to Gen Con, which is the big role-playing game convention in Milwaukee. And I went with the guys from Wizards of the Coast. So Peter Adkison and all of the artists, Anson and all the various artists. Good friends with them now. And they demoed, we played Magic on the trip, but it was all like photocopied cards. So we had like the first version of the game, and we played it in the bus, in the van when we were going there, and it was fantastic. It was like you could tell this game was just going to be so great. And so when Magic came out, I was already prepared for it. And so then I ordered as many as I could get my hands on for the comic book store. And so then when people would come in, I would demo the game and teach them how to play Magic So I was like one of the first people to teach people how to play Magic in Vancouver. And like back in that day, like we didn't know what we were doing, and so we would do things like we'd have an ante. You know, we both put a card down, and then whoever won the match got to keep the other person's card. And you'd be like, oh, some crazy dragon, that's cool. Oh, Black Lotus, whatever that means, you know. And so yeah, we had some pretty great times. And so I was, you know, I'm still in chat and, you know, talk to a bunch of the people from Wizards of the Coast. They've all sort of moved in other directions, but good times. Yeah, someone asking about Astronomy Cast. Yeah, we do Astronomy Cast every Friday. There you go. Yeah. All right, I think we've reached the end of the time. Over time. So again, thank you everybody for hanging out with me. I'm now going to set this to private, so all the overtime will be lost forever. But thanks for hanging out. It was really fun. And as I said, weekly Space Hangout coming up on Wednesday. Astronomy Cast on Friday, episode 600. And lots more good stuff. All right. Thanks, everybody, and we'll see you all next week. How do I stop this now? I may not be able to stop this. I've lost my... Hold on, let me find it. There it is. Okay, now I got it. All right, thanks, everybody.